Welcome back. Today we're going to look at a third example of a Fourier series. So I already went ahead and sketched this one and found the because it's really similar to the last one, right? It was just shifted up by 1. And you can see the period's 2L, the length is L. So, you can check this graph if you want to. It's just like the last one if you want it for reference. Except it's with L instead of pi, and it's shifted up 1. That's all. So now let's take a look at part B. We're going to solve for the variables. Solve for A naught. So for this one, we're given x plus L from negative L to 0. You're thinking, oh, that's fun, right? Negative L to 0, x plus L dx plus, here's the formulas, by the way, in case you're wondering, plus, what is it, L? From 0 to L dx. That one's really easy, right? So let's go ahead and do this really quickly. I can do this in my head really quick. Both of these at the same time. If you take that L out, that L's going to cancel. That's it. And this will become the same exact thing, but from 0 to L. Okay, so then we would have 1 over L is negative L over 2 minus plus L negative 1/2. Oh wait, this is squared. Negative L over 2 plus 2L is negative L over 2 plus 4L over 2. That is 3L over 2. So A naught is 3L over 2. Okay. Let's take a look at A sub n. A sub n, see the formula there? 1 over L, negative L to L, well, negative L to 0, x plus L. And you're thinking, oh man, this sucks. Well, it kind of sucks. This would be sine of what? No, this is cosine first. N pi x over L plus 1 over L, 0 to L times cosine. And I can tell you right now, because we know these cancel, this is 0 because sine of n pi is 0. You can see cosine of 0 is 1. I'm sorry, sine of 0, when you integrate it, sine of 0 is 1. Sine of, you plug in L here, comes n pi, sine of n pi is 0. Same thing's going to happen over here with this one here. So, we're just going to be left with right? That's all we're going to be left with, because you can see here the exact same integrals over here, but from negative L to 0. Remember, and then it doesn't matter. Remember, sine of negative n pi, because that's what we're going to end up with over here, is negative sine of n pi. It's still going to be 0. So this is all we're left with. Let's integrate. This would be the integration by parts. L over n pi sine n pi x over L. So now we have uv minus the integral v to u. We can take this out. dx. And I forgot my bounds. So now this becomes, if we evaluate that, that's 0 and 0 again. Right? And then we look at this one over here. Plug in 0. Well, we have to integrate it. What am I doing? N pi x over L. Okay. This is plug in 0. That's a negative L over n pi. Minus plus L over n pi cosine n pi, right? Because remember, cosine of negative n pi is cosine of n pi. This becomes, I'm going to pull out an L over n pi. And I'm going to distribute in the negative. So I'm doing two things in one step here. And I'm also plugging this in here. Right? Remember, the cosine of n pi is negative 1 to the n. That is an n, not an h. Oh boy, okay. Now remember, you could leave it here, or you can simplify this further using our even odd cases. Let me just find this to make sure what I have so far is correct. So, we could say, well, if n is even, a sub n is 0, right? Because 1 minus 1 is 0. If n is odd, a sub n is going to be 2l squared over n squared pi squared. So this is what we're looking for. Okay. Now let's look at b sub n. One over L, negative L to 0. This one might be a little bit more annoying to integrate. I'm going to immediately split this up. So I'm going to write out the x plus L integral into two different integrals to start out with. That's what L sine, yes, negative L. Well, this should be, yeah, L sine n pi x over L. And then the last term, the second half, was 1 over L, 0 to L, L times sine of same thing, right? See, if only these were cosines, they'd be 0. But unfortunately, we have to integrate them. But they're not too hard to integrate, right? You can see here we have a lot of things that are going to cancel. So let's do the integration in one step. Trying as being as efficient as possible. Negative cosine. Right. So then we have UV. Yeah, this one's gonna be a little bit longer. This coefficient, a negative Lx over n pi times cosine n pi x over L. That's our UV integrated, over negative L to 0 minus integral. I'm going to pull out that negative L over n pi. We're just left with this times dx. And then these other two integrals over here will become negative L over n pi cosine n pi over L. I'm out of space. And then plus, same exact thing, but evaluated from 0 to L. Okay. So let's take a look here. I see some nice things here that are happening. Like for example over here, this is 0. Because this is the only nice thing I see happening actually. The other things we have to evaluate. Alright, so let's look at this first one. Plug in 0, that's just 1. Plug in negative L. That would be... Wait. Plug in 0. That would be 0. Whoa, what am I doing? Okay, plug in negative L. This would be negative times a negative times a negative, which is a negative. L squared over n pi times cosine n pi. And then we have the next term. Plug in a 0. That is that would be minus L over n pi. Is that plus? Wait. I messed up on my my notes again. Integral sign is negative cosine. Whoops. I have messed up in my notes. Okay, well, it looks like I'm on my own from now on. You've got to be kidding me. Let me just double check. Yeah, it looks like I messed up in my notes. Okay, so then this would be... That's okay, I can still figure it out. Minus L over n pi plus... Well, this would be times cosine n pi plug in L for this next one. Stays negative. Wow, I really messed that one up. What was I doing? Am I sure those both are negative? Oh, wait a minute. It's 0 minus. This should be plus. Sorry, we're all good. This is minus. Yeah, minus L over n pi. I did mess up in my notes though. I don't know how I ended up with the right answer. I have no idea. I definitely messed up in my notes. When I integrated, I wrote it as positive cosine. I don't know how I ended up with the right answer. Okay. Yeah, now that's correct. Okay. So let's take a look. I don't know. I must have been looking at something when I did it in my notes. Because there's no way. Yeah, this would just become negative 1 to the n, right? I'm applying. Ooh, hold up. These cancel. Wait, I can just cancel them right here. All right. Okay. I think this is it for B sub n, right? Let me scroll down, take a look. Yes. This is, in fact, correct. And now remember, we can use, I don't know if I use this yet, but in my, you could keep it like this. There's nothing wrong with it. It's actually pretty simplified, but I like to get rid of negatives. Remember, any negative 1 to the n is the same thing as negative 1 to the n plus 1. If you want to see how that is, go to that simplification video I have. Okay. Now we have all the terms. So we can write the answer. What's A naught? So A naught over 2. We have 3L over 2, it looks like. So then we have 3L, this would be 3L over 4, right? Plus summation. Well, hold up. We have 2L squared over n squared pi squared for n odd. What did I say? 2L squared over n squared pi squared. This would be cosine n pi over pi, because the length is pi, times x. Pi's will cancel. Okay. Wait, is our length pi or L? No, it's L. What am I? I'm thinking of the last example. So sorry. N pi x. So sorry. That's my fault. That was the last example I'm thinking of. Now we do have one normal summation here. Sorry, my summations look awful. L over n pi times negative 1 to the n plus 1 times sine of I'm having brain farts, sorry. Okay, because I was thinking, I keep thinking ahead. Because this is simplified. You can see we can take out 2L squared over pi squared. And plus, remember, n odd is equal to 2m minus 1, so I'm going to go ahead and change this. There's two ways you can write this. Is what I'm gonna say right now. There's two ways you can write this, okay? So what I'm gonna go ahead and do. Okay, what I'm gonna go ahead and do is I'm gonna do this first. There's two different ways you can write the answer that I think is acceptable. So this is a little bit tricky. Technically, what I'm gonna write here is fine, though. To be honest, that's a no. This should be from. I'm not gonna take anything out yet. For very good reason. Actually, no. Yes, I am. I will take this out. Okay. So then this would be 1 over, well, cosine n pi x. Yeah, I'm going to keep it like this. That's quite a lot to write. And then we can take out an L over pi. And this is a perfectly acceptable answer, you know? -1. And I am running out of space. You know what that is there. Same thing as the last line. So, this is a perfectly acceptable answer. But you'll notice, as we increase in m by 1, we're increasing by the same amount for both intervals, so we can combine them. However, because I took out the L over pi and the 2L squared over pi squared, those can't be, those have to stick with the terms that they're with, if that makes sense. They can't just be taken out. So it would have to be kept like this, or if you wanted to rewrite it under one summation, you would have to bring all that inside. And then take out the common of those, if that makes sense. So let's take a look. Say or plus, this would have to be, we're gonna write them as k, or combine sums, where we're gonna use k, just like the last problem. This would be 2L squared over pi squared times 2m minus 1 squared times cosine. Yeah, hold on. This is going to have to be moved. Over L plus L over pi n equals 1. Sorry. Plus L. Let me do this. Oh, I fit that one. Okay. So you can write it like this, and then you can take out what's common in both of these. So you can see we have an L over pi that's common in both of them. So you can then write it like this. times sine n pi x over L. Okay? Now, in theory, there should really be brackets around this or parentheses around this in the sum, right? So this would probably be the final answer. Or you can leave it up here like this. Both completely acceptable answers, you know? They're both the same exact thing. They just look different. Okay? So that was a little bit longer one. I believe the next two problems are shorter. I believe we will have some nice symmetry occurring in the next two examples. So I will see you for those examples.